Welcome to Episode 3 of Module 2, API Gateway and Service Design. APIs act as product contracts, and service design decisions will shape your roadmap, partnerships, and architecture for years to come. This program is brought to you by the Series of Thoughts team as part of the AWS for Product Teams series.
Today, we bridge product and engineering perspectives on API design, covering everything from high-level contract decisions to hands-on AWS implementation. We will discuss APIs as product contracts, building with API Gateway and Lambda, event-driven design using SQS, and key takeaways. An API is a promise to every consumer that depends on it. When teams build against your API, they are taking a dependency on your design decisions. Breaking this contract results in rework, migrations, and eroded trust. A poorly designed API becomes a permanent constraint on your product roadmap. Before writing a single endpoint, ask, who are your consumers? Mobile clients need bandwidth efficiency, partner integrations need stability, and internal services need speed. Building an API for your data model instead of your consumers is the primary source of long-term API debt. The choice between REST and GraphQL is a product decision based on consumer needs. REST is resource-oriented, great for stable public APIs and easy to cache. GraphQL is client-driven, ideal for complex UIs and internal consumers with varied data needs, but harder to cache and requires schema governance. Synchronous versus event-driven architecture is another product call. Synchronous means the client waits for an immediate response. Event-driven, or asynchronous, means the client fires a message and moves on, allowing the backend to process at its own pace. This decouples systems and is resilient to spikes. APIs that expose internal data models or implementation details create brittle contracts. As your internal model evolves, you face a painful choice: break consumers or carry old design baggage. Design your API surface for the consumer's mental model, not your storage layer. Amazon API Gateway acts as the front door to your backend. It handles traffic management, authorization, rate limiting, and routing without requiring any custom infrastructure code. API Gateway offers critical features. These include authentication and authorization using IAM, Cognito, or Lambda authorizers. It also provides rate limiting and throttling to protect your backend from traffic spikes. You can manage versioning and stages and benefit from built-in CloudWatch observability for metrics and error rates. The most common serverless API pattern uses API Gateway for the HTTP layer, with Lambda executing your business logic. API Gateway translates the HTTP request into a Lambda event payload, invokes the function synchronously, and maps the return value back to an HTTP response. Request validation stops bad data early. Without it, invalid payloads reach Lambda, forcing defensive checks and producing confusing error messages. With API Gateway validation, using JSON schema, malformed requests are rejected before Lambda invocation, leading to cleaner code and faster feedback. Usage plans and API keys allow you to tier access by consumer type. First, create a unique API key per consumer. Second, define a usage plan with throttle rates and quotas. Third, associate the API keys to a plan, allowing API Gateway to automatically enforce limits. Custom domains make your AP feel like a first-class product. Use Amazon Route 53 for DNS and AWS Certificate Manager for a free TLS certificate. API Gateway maps your custom domain, like api.yourproduct.com, to your deployed stage. Amazon SQS, or Simple Queue Service, is the backbone of event-driven and decoupled architectures on AWS. It provides durable, scalable message queuing that absorbs traffic spikes and enables asynchronous processing. Not every action needs an immediate response. Event-driven design decouples when something happens from when it gets processed. This separation delivers faster API responses, greater resilience, independent scaling, and natural support for retries. Message-driven architecture relies on three components: the producer, which sends messages, the SQS queue, which durably stores and buffers messages, and the consumer, which pulls and processes messages independently. This architecture provides resilience and decoupling. Standard queues offer maximum throughput and at least once delivery, suitable for most background processing. FIFO queues enforce strict ordering and exactly once processing, ideal for financial transactions. Dead letter queues collect failed messages for debugging. Visibility timeout ensures a message is invisible while being processed, enabling retries. Decoupling with a queue means components can scale, fail, and deploy independently. When systems are tightly coupled, a slow consumer backs up the producer. Queues allow you to throttle processing without dropping requests and replay messages from a DL queue after fixing bugs. Lambda natively integrates with SQS as an event source. AWS manages the polling loop on your behalf. Messages are processed in batches, up to 10,000 messages per batch in standard queues. Failed messages retry automatically and route to the DL queue after a configurable number of attempts. Amazon SNS provides pub/sub fanout messaging, unlike SQS, which is point-to-point. One event published to an SNS topic can be delivered to multiple subscribers, including SQS queues, Lambda functions, or email. This enables services like fulfillment, analytics, and notifications to process the event independently. The canonical serverless pattern uses API gateway and synchronous Lambda for client interactions, handling security and observability. The SQS and Lambda layer handles deferred processing, ensuring fast response times and resilience to downstream failures or traffic spikes. We've covered several AWS services: API gateway for the managed HTTP layer, Lambda for serverless compute, SQS for durable messaging, SNS for pub/sub fanout, and Route 53 for DNS and traffic routing. A PI design is a long horizon decision because every API is a commitment. Design choices today become constraints in the future as partners and internal teams depend on your stable contract. Rigorous API design is essential. The data model trap is building an API that directly mirrors your database schema. When your data model evolves, all consumers must also change. Design your API for the consumer's task and mental model, not for your ORM. Design for the consumer's workflow by grouping resources around intent. Version your API from day one, using a prefix like /v1/. Return only the minimum necessary payload to prevent leaking internal details. Document errors as carefully as successful responses. Skipping API gateway to move fast often leads to painful retrofitting later. The sustainable approach is to include API gateway from day one. This immediately provides rate limiting, request validation, centralized auth, metrics, and stage-based versioning, saving significant time under production pressure. API Gateway's hidden gift is automatic observability. You get latency, error rate, and request count metrics in CloudWatch with zero custom code. It automatically tracks 4xx client errors and 5xx server errors, providing the foundation for SLA baselines and production debugging. This chart serves as a decision guide for when to use synchronous versus asynchronous communication based on latency, failure blast radius, and delivery guarantee requirement. The most important takeaway is to design for your consumers, not your data model. Your API is a product, not a database view. Using API Gateway from the start gives you critical features like rate limiting, auth, versioning, and observability for minimal effort. In the next video, Module 2, Episode 4, we will explore architecture decision records. ADRs are lightweight documents that capture the context and rationale behind crucial architectural decisions, making your team grateful by documenting not just what was decided, but why.